In this video, I'll be going over two main types of studies, observational studies and experiments, and talk a little bit about the types of conclusions that you can draw from these. Right, so as I mentioned, there's basically two main types of studies, observational study and experiment. There's a lot of other different types of names that you might hear for all sorts of different studies, but we're just going to kind of mainly focus on just these two main categories. All right, so let's start with observational studies. In an observational study, researchers don't directly interfere with how the data arise. That is kind of, as the name might suggest, they just observe from afar. And so, that's, great for collecting data, but it also means that the researchers do not have control over how the treatment is applied. A lot of times you'll see in observational studies the names treatment group and control group are still used even though there isn't like an actual application of the treatment on the part of the researchers. But yeah, in these, basically the researchers aren't interfering directly, they're just kind of seeing data as it comes up. On the other hand, experiments are basically very controlled studies in which researchers use randomization and control groups to determine if there's a causal connection between two variables. And so basically the idea behind this is that it's a very controlled environment. You have two groups or more, and you're basically just changing one thing. And you're doing that to see if that one thing causes a difference between the groups. And basically the idea behind this is that if you change one thing, then if you see a response in one that you don't see in the other, then there's only one thing that's different between the two groups, so therefore it must be caused by that one thing that you changed. So in an experiment, you do have to make sure that it's very controlled, and there's several conditions that you have to fulfill to actually be able to make that causal statement. And so participants must be randomly assigned to groups, and there must be a control group to provide that baseline. All right, so let's kind of break down those two parts. So why randomize? So let's consider a study about exercise and test scores. Participants take an exam, then are given a choice of two groups, exercise and no exercise. The exercise group does 30 minutes of cardio at least 3 times a week, while the no exercise group has no requirements. After a month, participants take a similar exam, and researchers look at whether there was an improvement in scores. So what might go wrong with this? Well, if you think about it, participants were chosen the exercise or no exercise group. Now, what might cause participants to choose one group over the other? Well, maybe participants that are just more motivated would choose the exercise group, and participants that aren't particularly motivated would choose the no exercise group. And maybe the more motivated participants would tend to do better on the exam the second time around. And so, it could be possible that motivation is actually the factor that causes both of those things. And so therefore, because we didn't have randomization, we can't take that out of the equation. The randomization basically just kind of makes sure that these factors that we can't control, they're kind of evenly split between the treatment and the control group. So why control groups then? Why don't we just kind of apply one treatment and see what happens? You could just have the baseline as at the beginning. Well, so let's take this example. If you found out that a drug reduced heart attack risk by 10%, seems pretty good, right? But what if you learned that a placebo group had their heart attack risk reduced by 11%? Well, now this new drug doesn't really seem as good. It actually did worse than the placebo. So it seems to be the case that just taking a drug would just improve outcomes. Right? So basically in this way, we want to know if there's a real effect or a placebo effect. Right? And so one other thing that we want to do in experiments is something called blinding. And so there's this idea behind the placebo effect and all that kind of thing. So if you know which group you're in, let's say you know that you're in the treatment group, you might just have better outcomes because you think, oh, I'm getting the treatment, therefore I should be doing better. Whereas if you're in the control group and you know it, you might not do as well just because, well, that you're in the control group, it shouldn't be the same. And so to combat this, we use blinding. Basically, a study is single-blinded if the participants do not know which group they're in, and it's double-blinded if the researchers also do not know. This might prevent stuff like researchers applying preferential treatment to people in the treatment group. And so you do want to take that out of the equation as well. Right? So in order to make statements about causation, we need to have a randomized controlled study. We have to have this experiment in order to make statements about causation. There is, if you kind of get further along and get more into advanced methods in statistics, there's this thing called, causal inference, and they try to make causation statements from observational studies, but that's kind of far along the line, and basically it requires taking into account a lot of factors in order to do it. But so for now, just kind of think about it as experiments. You can make causal statements, whereas observational studies, you can talk about correlations, you could talk about associations, but you cannot make causal statements.